Welcome to the Web Platform Podcast, a developer discussion that dives deep into all things web. We discuss topics relevant to developing for the modern web and the web platform of today, tomorrow, and beyond.
This is the Web Platform Podcast, episode number 165, where we're going to be talking all about unit testing best practices and tools. I'm your host this week, Danny Blue, and with me as always is Leon Rebel.
Hello.
And Amal Hussein.
Hello, hello.
Before we get into our discussion all about just the world of unit testing, we're going to let Leon give us This Week in Web in 2 minutes or less.
Thank you, Danny. So first of all, based on a GitHub issue, it looks like Angular is getting native Shadow-DOM support, which is quite exciting. Front-End Con 2018, which is happening in Warsaw, Poland this year on the 4th and 5th of December, has just opened its call for talk proposals. So if you've got a talk you'd like to give at that, check out the link. And the official ECMAScript 2018 language specification has just been published, so if you need some light reading before bed, I recommend you check out that full specification. So there's some nice example of some threads in Node using the experimental worker threads. So in This Week in Web, in the last episode, we talked about the web worker equivalent in Node. This link provides a nice example of actually using it with behind the experimental flag. Safari Technology Preview 60 has just been released with loads of improvements and fixes. This includes some items related to web animations, for example, CSS animation taking precedence over CSS transitions. And finally, continuing on the browser theme, Firefox 61 is now available, which includes parallel CSS parsing, which sounds very fancy. So check the link to find out exactly what that's all about. And that's everything from me for This Week in Web. Thank you, Danny.
Thank you, Leon. As always, it seems the web hasn't just imploded since we last talked about it. So that is good to hear, sometimes worrying. So this week we said we did want to talk about unit testing. We've done some shows about unit testing before. For this, we want to be pretty broad where we talk. We want to start very broad where we talk about just what it is, maybe what some of the challenges of unit testing are, and some of the tools that different frameworks and different techniques to actually getting there. So Amal, why don't you kick us off and help describe exactly what unit testing is, or what is a unit test?
Sure. And thank you, Danny. So this topic, just for some background knowledge, was evangelized by yours truly, because I love testing. And I also just led my first testing workshop with Gleb, who was on the show last week, talking about end-to-end testing with Cypress. And so I love unit tests. I've always been, that person on the team that's advocated for testing and help people write good tests. And now I write tests for the web platform, which is like a whole different level of writing tests. Writing tests for JavaScript specifications, for web platform API specifications. And so I have a newfound appreciation for unit tests. And so I would define unit tests as a block. A unit test is like a block of code that tests another very small block of code, right? And typically that's a method, or a function. And so the contracts between what that function is supposed to do are tested in another block of code, which should be called your unit test. And it's supposed to only test that one thing and one thing only. And I think a lot of the pain around unit testing comes into play in the JavaScript community, especially because we're often testing several things at once and we think it's a unit test. And I think that's where a lot of our problems start.
So a lot of this actually comes down to defining a unit. And again, so there are a bunch of different types of testing. For this right now, we are referring to unit testing. And so a lot of it is defining what a unit is and defining what that is to test. So can you give us an example of what a unit that you would test is, for maybe a little bit of context?
Sure. So if, for example, if I have a function that's supposed to return a formatted username, right? And that function maybe, triggers two REST API calls, which, take data, transform it, merge it together, and, at the end, return the formatted username that I want. If I would be testing that wrapper function, I'm stubbing out the behavior that's being triggered inside of that other that's being triggered inside of that function, and really kind of focusing on the output of what that function is supposed to give me, right? So through using mocks, stubs, you're able to manage the side effects that would be generated by that function.
It's got
And
to be
so
deterministic, right? So you wouldn't test something which obviously had variable results based on a REST call or something like that, which is why you stub it out so you know exactly what you're going to get back, so you can compare against what the expected value is. That's right, isn't it?
that's exactly it. So your tests have to be deterministic, and through using mocks and stubs, you're able to get that determinism, and you're also able to test that, hey, the contracts are established, right? So when I create a stub for a function that calls another function, or that's called inside of another function, I can make sure that that stub is triggered and that's called, right? So if somebody removes it, the test will fail because, hey, like, I expected this function to be called, even though I don't care what it does. I just want that thing to be called. And so, you can kind of ensure contracts in your code a bit better that way.
So we've actually jumped forward a little bit further. So we're already talking about
Stubbing.
mocks and stubs and things like that. But because a lot of people will also read. So one, we should cover what those are, and then also address when they're a reasonable thing to use. Because I'm sure a lot of people have probably seen articles and stuff out there that say, like mocking is code smell. Like there are a lot of things out there where you don't want to stub out things. So why don't we start with, so we've kind of talked about like what a unit of functionality that maybe you want to test is, what you want to, like wanting that your piece of code to be deterministic, like Leon said, so that we can verify our result. So now let's talk about the other two parts you said. So let's talk about like maybe what something you would mock would be, and why that would be an acceptable thing to mock versus something else.
Yeah, so I think that's a great that's a great question, and I think we should back up a little bit. And I think there's a lot of terminology that we've thrown around, right? Mocks, stubs, spies, and I think there's been some shifts also in the community around some of the terminology. So I don't know, for those of you who might have been familiar with a framework like Jasmine, right? This like awesome all-in-one framework. Everything was a spy, and if you right, the concept of like stubs were built into spies, and Xenon is another great tool that a lot of people use. They have spies and stubs as separate things, and Jest is a whole, is a tool that's becoming more and more popular by the day. Even in communities that are not using React. And it's it doesn't even have the concept of stubbing, or because everything is kind of a mock, and so there's a lot of really confusing terminology, but I think and it's different depending on what library you're using. But I think the basic idea is, basically you can create an abstraction, a black box around what a function is supposed to be, and when you do that, you're stubbing it. And so if you're completely stubbing it, that's when you would use a word like stub, for example. And if you just want to see what the behavior of that function is, that's when you would maybe use the word like spy, right? So you're spying on it because it's still able to perform its normal duties, but then you're not like disrupting its behavior, right? So that's the difference between stubbing and spying. And so when you would use these techniques is really for in my opinion, is when you want to manage your side effects, right? Because, for example, there's different types of code that you're testing. Sometimes you're testing pure functions. Sometimes you're testing asynchronous functions. You're testing UI code, right? Like you might be checking to see if a DOM element contains, an ID. These are all different types of unit tests. And so it's really when you want to manage the side effects of something, or you want to be able to examine the contents of a function without disrupting it, that's when you would really want to use spying and stubbing.
Okay, so the other word that got thrown out was also mock, um, which I think we should also cover real quick. And an example of that would be, so when we have a unit test, which are different than end-to-end tests and different than, just different than other types of testing, we're just trying to test this one piece of functionality. And so we might have a networking layer of some sort that is responsible for just making calls to the back end and returning a result. When we're running our unit tests, we don't necessarily want to actually be making those calls to the back end. So that is a place where providing some sort of a mock networking layer is valid, so that say you have, so similar to what Amal was saying, so you have a function that let's say it's a function that returns a promise. It's responsible for making a call to the back end and then returning the formatted username that we expect. Since we don't want to actually make that request, what we can do is we can provide some sort of a mock that will say, okay, when somebody's saying, get user, which is to get the user from the back end, we're going to provide our own implementation of get user so that it can return a promise, and we can say this is the payload that is expected, and then we can kind of we can avoid doing things in our code that we don't really need to care about, which also then lets us do things like test when there's an error at that networking layer. We can figure out, we can test for exactly what is happening. But there are most things you really don't want to mock. So for example, if you have a function that's composed of several other functions, you don't want to create a mock of any of those other functions. Unless there's a specific reason that they can't be called exactly the way they are, you should just let them be called. The code should be called in as realistic a scenario as possible.
Yeah, and it's like, you want your tests to be really quick, right? So, especially if you've got hundreds or even thousands of them, if they have to do, REST calls or something like that, it's seriously going to slow things down. But additionally, obviously, back to the deterministic thing is you need to be able to assert the expected value. And obviously, if there's a chance that the server or something else could return something you weren't expecting, you're not going to be able to do that. So you need to know exactly what you're going to get back to be able to test for the proper output correctly as well.
Yeah, and also just to kind of drive that point home, what you're testing for is, you're not testing content when you're writing unit tests. You're testing functionality, and so it doesn't matter what gets returned. Like that formatted name can just be foobar. It doesn't actually matter. What matters is that foobar gets inserted in as lowercase, and it comes out uppercase, right? And so it doesn't matter. The actual content doesn't matter. It's the transformational functional piece that you're testing. But I think I want to back up just a little bit, which I think you guys touched on a couple of points around, hey, I don't want to make REST calls. And, I think a lot of the reputation, like sometimes unit tests kind of have a bad reputation in some teams because they're seen as like unreliable, right? Or I have tests that I've seen a lot of teams that have like intermittently failing tests, right? That are just like never addressed. And so what happens is there's just this lack of trust in the unit tests. But the reality is, like, companies like Google and Facebook, they rely on their unit tests to be able to just push to production without any kind of manual QA, right? Of course, the developer is responsible for testing their code and writing test coverage, but that's about it. So I think that it's a combination of having unit tests and integration tests, right? And I think a lot of times people write unit tests that are sort of integration testy, and they don't realize like how dangerous that is, right? Mm-hmm. So if you're actually making REST calls in your unit test, like that's horrible and bad, and you're gonna have lots of race conditions because these are runners that are not expecting like that type of weight, they're not, and so right. So just making sure that when you're writing unit tests, that they're actually properly, like all of the side effects are properly managed. That's, I think, the biggest hurdle, I think, for writing good tests.
So, Amal, so we've talked about some of the maybe, the things that might make a bad test, doing these kind of things, not testing anything that's deterministic, or maybe doing REST calls, those kind of things. But what makes a good test? Like, where's a good place to start when it comes to best practices? Could you kind of take us into that journey?
Yeah, so I think what makes a good test is one that's like a good suite of tests. It really starts with organization, right? So I think leveraging things like describe blocks, it blocks to write descriptive, descriptions and try to organize your code as if though like your tests as if though they're literally mirroring the code, right? So it's just easy to understand what's going on. They kind of serve as a good place for documentation as well. So the other good thing that another thing that makes good tests again is managing your side effects, which we've already discussed, but also making sure that your test is actually testing the thing that you think it's testing. And I say that because I see a lot of problems with like asynchronous JavaScript tests, and where the unit tests maybe are not being treated as asynchronous, right? And so what happens is you have these race conditions, and again you get this weird intermittent failure, and or you have something that's just a false positive, and that happens a lot with like promises, and if you're testing the error case, for example, and you're not rejecting in your tests, and so it'll just pass without you realizing that it's actually not testing anything. And so I think people tend to get very hung up on like this concept of like TDD, test driven design, and a lot of discussion and debates happen around should I be writing tests first or after, or I don't really think that matters. I think you should just write tests, and I don't think anyone should judge you as to when you write them. But I think what a very important principle that we can borrow from TDD is this concept of like red green refactor, right? So you have a failing test, then you make it pass, and then you refactor your code. So the red part is the most important part, which we can borrow from TDD, which is we want to make sure that like when we write tests that are passing, that we can make sure that an edit in our code or an edit in the test will make it fail, right? And that way we want to make sure that like we're testing the contracts appropriately.
Yeah, I mean, very simply, you can't totally be sure that a test is passing if you haven't seen it fail at one point. And I'm sure everybody's run into that at some point as well, where like everything's running along fine, and then everything's running along fine, and then you find a bug or something, like, oh, why didn't my test catch that? It's because it wasn't actually, like the correct thing wasn't being called. Your assert statement was in the wrong place or something like that. So yeah, that is that is always extremely important, as weird as it sounds. But like you said, the red green refactor thing, right? If you see it fail and then you see it pass, it works, and then you can change whatever you want, which is kind of the point of that. So you have it. So if it's like true test driven development, like you said, pretty much what happens then is people end up writing their tests first, which some people like and some people don't. So you would actually like write out your test case, and you would say, okay, I expect, say you have a function that's adding numbers, just will add an array of numbers together, and then you write the function out, pass its arguments, and say I expect when I pass in an array of 1 and 1 that the result is 2. You haven't implemented the function yet, so obviously that's going to fail. You then go back to your function, implement it until it passes, and then after it passes and everything is acceptable, then you can start refactoring your code to make it better. So, and you can do similar things without going full test driven development here, but I agree with you very much, Amal, that seeing it fail is very important.
Yeah, it's super important, and I also think it's super gratifying. I love seeing green, and I love seeing green even more after something red. So if anything, it feels good. But so I think another very important element, I think, for web developers writing unit tests is just making sure that besides it being organized, but that you're managing your tests in a way that makes them easy to change and scale and edit, right? And so what I always recommend to web developers is to have one set of fixtures, which kind of serve as your mock data, right? And having one place where that's managed so that all of your unit tests are using the same base for the like initial payloads that you'd be getting, for example, from a server or a REST endpoint. And so being able to have one set of data that you uh, transform during your unit tests, like that's one easy place to change something, right? And as opposed to having like mock data all over the place that's hydrating or that's required for kind of different types of setup. So that's definitely a good thing to be able to do. And I think clean your testing basically follows a set of patterns, right? So you're setting up for your test, right? So you're getting the required data or whatever ready, and then you're actually executing the code, and then you're executing the code, running your assertions, and then you're cleaning up, right? And so just making sure that you're always following that setup, assert, cleanup pattern, because especially with DOM tests, what happens is, sometimes folks are leaving things inside of, they're leaving things behind that, affect state, or they're sharing state between tests and not realizing it. And it's fine when everything runs in the same order all the time. But, the minute it doesn't, you have the intermittent failures, right? So every single test that you write should be able to run independently of another test. And so just making sure that you have a clean organization for how you set up and hydrate your requirements, and making sure that you're always cleaning up so that you're not doing those things that cause like very strange bugs.
Superb advice for sure. So obviously we're talking about unit testing. Would now be a good time to kind of go into the different types of tests that you can do, such as pure functions, etc. Is that something you'd want to talk about, Amal?
Yeah, sure. So I think, yeah, when you're writing your unit tests, you should kind of, for your team, like you're kind of developing a little bit of a playbook, right? And so after, I think for like applications that are a bit more mature, you have like a set of helper functions. You have, for the back, if it's a node application, you have your models, you have your controllers, etc. You have kind of these repeating patterns that occur, right? And so I think knowing what you need to test and knowing how to test, a particular thing is really important, because hey, you can avoid making mistakes, you can avoid overcomplicating things, right? And so something is a pure function. It's really the easiest thing to test, right? So it's just something that adds two numbers together, for example. So you can test it by just giving it any two inputs and expecting, like, if you give it 2 plus 2 and 2, then it should always return 4. And so asynchronous functions, again, knowing that something is async is really important, because you can account for that when you're writing your tests. Component and UI tests are, it was really difficult, like even just 5-6 years ago. It wasn't the easiest thing to write unit tests for the DOM, but it's pretty easy now. I think React kind of was the first major library that I think made it easy. I think Angular took a good stab at it, but I think Protractor was Protractor was it made it sort of easy, but I really personally think that React really had it was the easiest like way to test a UI framework that I had seen. And
well, so also like Protractor. So this is also some of the space where we get into the difference between like unit tests and end-to-end tests. Mm-hmm. So like Protractor, for example, exists where you're not actually testing the code. It's when you're acting almost like that's when you start getting into things where it's like, oh, I'm trying to automate my my manual testing of like the user goes to this page and they click this button, that type of thing. But I am totally with you. It's just also want to make sure that we point out that like that this is how easy it is to even start getting into the different types of tests that you can write beyond just unit tests.
Yeah, and so React components were a breeze to test with JavaScript, and I think a lot of that ease came from the fact that, hey, everything in React is JavaScript, right? Even though JSX is this like magical thing that gets transpiled, I think that's a big factor for what made it easy to test. And so with UI, with these DOM components now, we have this new concept of snapshot testing, right? And snapshot tests, basically allow for any serializable thing to be stored and saved like a the rendered output of, for example, a REST API or an element with children, right? Can be saved, and so we know that when we run this test, like this DOM element should always look this way. And so I think snapshot tests can be very useful for DOM, but I think only in some situations, not all. And I definitely think snapshot tests for APIs are very useful. And so making sure that you're not overdoing it, just creating a snapshot of your entire application. Like don't be lazy, because there's lots of things that aren't really captured, with snapshot tests. So
Yeah, and to be, I've been really interested in snapshot testing. I feel like I've just started hearing about it in the past couple of years. I don't know, Mom, maybe you have. Well, I know you have more experience with it than I do, but it's a very curious thing, because it does seem easy to make it be like, oh, I'll just, because I guess the idea would be that I'll run this function and then I expect it to be this. The DOM is a good example, right? It's like, after I run these things, I expect the DOM to look like this. I mean, there have even been snapshot, like literal snapshot testing, where like it would actually take a screenshot of your browser or something like that, and then at the end it would actually compare and be like, are these two pixel for pixel the same? So snapshot testing is really interesting, and I actually haven't heard a lot about the drawbacks of exactly what snapshot testing are, but you said some stuff can get lost.
yeah, like for example, there's many different states in your UI. Like click events are not exactly going to be captured, for example, right? Like uh you click this button, like I don't know, how would you capture that in a snapshot, right? So there's like the JavaScript. I think it's like it's really mainly for the DOM. I think it's the contracts, it's where the HTML meets JavaScript pieces that I think are harder to capture with snapshot tests. But for APIs, I think they're really useful. I think for anything that's like a large serializable thing that's going through a bunch of transformations, it's pretty useful. Just know that tools like Jest make it very easy to like update your snapshots in place. But again, it makes, like, just think about it like you have this human that's reviewing this giant diff. Just, are you really sure that that human is going to review it correctly every single time? I don't know. And so I use snapshot tests with caution. I also make sure that you're using them alongside other tests. I think relying on them for your only source of unit tests is, I think, a little bit risky. So
if you want to kind of go beyond that, you kind of getting more into the full on end-to-end testing, aren't you? Like as Danny described, where you're writing some automation tests which are pretending to be a user, to capture the clicks and compare the UIs and all those kind of things.
Yeah, that's exactly right. Just make sure. I think it's very difficult to do a snapshot for a unit test, right? Because snapshots are like so large. They encompass many different things, right? So if you're relying on your snapshots to do all of these different things, you might as well just do an end-to-end test, and I think that's much more valuable for your application.
So we've already started talking quite a little. Well, we've mentioned quite a few different tools and libraries, test runners, etc. So I'm wondering if we wanted to kind of transition into that area, because there's so many. It seems like there's a new tool out every week, just like with everything with JavaScript. Of course, there's so many different tools, different test runners, different libraries, languages. How on earth does somebody kind of keep up with it? How do you kind of filter through all of the madness and really figure out what's the best stuff to use for a particular project?
Oh gosh, that's like the $1 million question. I can now say that I'm happy to.
I'm gonna say that's what the Web Platform Podcast is here to answer, the million dollar questions.
Wait, I don't get any checks for this. Do you? Hold on. Anyways, so tooling is like the developer's like best friend, and also like a greatest source of like angst, anxiety, like angry product managers, like you name it, right? It's just, anyways. Tooling for testing has gotten a lot better. The tooling ecosystem has all these different things. So we have runners like Mocha, Ava, Tape. We have runners like Jasmine that are like runners. They also contain, their own assertion libraries, mocking and stubbing libraries, etc. And we have assertion libraries like chai, expect, should, etc. Mocking tools to write stubs, mocks, code coverage tool, virtual DOM providers. Like there's ton of tools out there. I'm really happy to say that Jest has, I don't know whether it was foresight, but they have done the hard work for a lot of developers and have taken a lot of good tooling, put it in one package, and then they have a bunch of other custom things that are Jest only, right? But Jest kind of comes with everything you need out of the box. So it's a runner. It has an assertion library. It's got code coverage built in. It pulls in JS DOM for virtual DOM, so that like inside of a node environment you can say document, right, or window, right? You can, because for your DOM tests, they're running inside of a node environment, and you want to be able to have access to those globals that you have in the browser. And then they have snapshot tests, so there's a bunch of things that people would spend weeks setting up and tuning, that just gives you out of the box without any config. So Jest is not maybe something that everyone's excited about. If you want to go do it the hard way and use all these other tools and stitch everything together yourself, you totally can. I have yet to have, like, I've been using Jest for maybe about a little over a year. I haven't seen any major downsides. I think there's some things that I really miss about Xenon syntax, and I really wish I had Xenon. But other than that, I've been really happy with Jest. So.
That sounds really good. I think that's really important, because I think how difficult it is to kind of get going, I think puts a lot of developers off, perhaps. Like you said, you start off with, right, so what test run am I going to use? So you're going to do some research and you choose that, and you're like, right, okay, so then which assertion library, and does that work with the test run I've just chosen? And then mocking libraries, and so on and so forth. And it just gets too much. So the ability just to be able to basically choose one tool which makes those decisions for you certainly sounds very appealing. I think it will be for a lot of people.
Yeah. I mean, it's also with like a lot of frameworks make that pretty help you out with that a lot now. Like React has Create React App, which will help set up different stuff for you. Angular's got the CLI. Vue's got their own CLI. Preact has their own tool as well. So like a bunch of the different tools out there. Like Ember, like historically always had pretty good tooling. So luckily there are things out there that do help. Like you both said, like make those decisions for you, because I don't know if anybody's tried to. So like everybody knows I'm an Angular person. I don't know if anybody's tried to set up like Karma and
oh my god,
Karma and TypeScript and Jasmine by themselves. It can be like, you could do it, but it takes a minute. So it's one of those things where it's like, thank God the CLI does it for
a minute. You mean a year?
a minute? Yeah.
A minute.
Yeah, I'm pretty sure like 2 jobs ago, I helped like at least 3 teams set up their Karma configs, because it was complicated. And, I'm really happy in the front end community that there's this like push for like zero config, good defaults, right? If you want to add changes, go ahead, but like we're going to give you great defaults out of the box. And the really cool thing about Jest is you literally do not have to set it up. You just npm install jest --save -dev, and then you create a file that's either in a _tests folder, or that has that's just like foo.test.js, and it automatically picks it up. Like it's that good. And the best part about Jest is, I think if we didn't make that clear already, it's a framework agnostic test runner. So I'm using Jest right now in Node projects, and you don't have to use it. This is I think it gets very coupled with React, but it's really not. It's not just a React test runner. So it's pretty cool. And it's had a big makeover since version 15.
So Amal, I have to ask, but what is the integration like with TypeScript?
I don't know. I use JavaScript. Like, I can't answer that. But I don't see why. If you, I'm assuming there's probably like some plugin or some type of config thing that you can do to link in your transpiling and
Okay.
for your tests. Yeah.
But so it does have, so again, we're talking about like the, intelligent defaults and things like that. So so it gives you good defaults and easy to get going, but it does give you these hooks so people can write, I'm assuming people can write, transformers and like things like that, similar to people would for, like a lot of the ecosystems they're familiar with.
Yeah, and actually, I just Googled this while you were talking, and it looks like it has it by like it seems like it has support for it by default. It just needs the .ts
Cool.
extension. Yeah.
That sounds awesome. I might have to play around with that.
Yeah, it's pretty dope. So one of the other really cool things I like about Jest is, it was written by a team that has like thousands and thousands and thousands of unit tests, and so they have this. It's got the watch mode only reruns tests that for falls that were affected, which is just genius. And when you console log, I don't know about you guys, but when I put console logs in anywhere when I'm debugging, I always put like a unique marker, like console log here .1 or something. And you don't need to do that anymore with Jest, because when you get a console log, it actually shows you, hey, it came from this file, this line, right? It's almost like a trace, a console trace, but better. Because it's not. So it's really easy to write tests, to run them again. It's got a great CLI, lots of good built-in for doing all kinds of cool stuff with like spying, HTTP interception. So generally, like I'm really happy with Just. It's awesome, and I don't know. I'm eager to see the competitor rise. Because it's going to be a tough one to compete with.
So we've gotten into a bunch of very specific things now. So we're talking about tools. We talk about, so like everybody's got their own tooling that they're like. Amal, you're obviously a huge fan of Jest, which sounds really awesome. So it sounds like a bunch of people should go out and look at that as well. We've talked about what makes what make good tests. We've talked about some tools that you can use to get those tests get those tests going. I'm still interested in what a bad test is. We've talked about it a little bit, especially like ones that are they fail intermittently and things like that. But and I know I've seen them and I know I've written them, and I'm assuming that both of you all have as well. But can you almost give an example of like a test, like maybe even just a bad test that you've seen, whether it gave a false positive at certain times or it missed certain cases? Like what makes it, in order to help know, the same way that we want to see the test fail so that we can know that we can be sure when it passes it's correct. What's an example of a bad one so that when we compare it, we know, oh, I'm writing a good one?
I guess I can start here. I've seen lots of bad tests in my day, more than I'm willing to admit. But I think for me, the baddest of the bad are the ones that are they're so innocent looking. They're just like, oh, this is just some component that's being mounted on the DOM. Like, what harm can this do? Well, like this component triggers a bunch of async calls, and its children trigger a bunch of async calls, for example, right? So without properly stubbing the side effects for this component, you have a bunch of weird intermittent tests that are failing, not just because like it's not just this test, right? It affects, because the things are kind of resolving at all different times. Random tests are affected that don't, that aren't bad, just because there was an error thrown while this test was running or something like that. So there's, I think those are like, they look innocent, but they're not. I think those are the worst kind of tests for me, because they're the hardest to kind of like suss out.
The ones that I've seen and also written in the past are ones that ignore the complicated cases. We've mentioned code coverage a couple of times. What code coverage is that it ends up, it's like a report of some sort that will tell you which pieces of your code have been run through a test. That's all it tells you. It doesn't tell you how well it's tested. It just means that, yes, this function was called and this parameter was used, like this fork of the if statement has been called, things like that, which are, it's extremely handy. But sometimes you can get a little bit too much into, well, I just want to make sure every part of the tree is covered. And the test cases themselves aren't super well written out. Because anybody that does a good bit of testing, like, your code will actually, the way that you code things will sometimes change a little bit as you're writing your tests, because you're like, oh, well, because I want to write, and I can write it this way. It will be an easy thing for me to prove it works, which is what a test is. And so it's when there are tests that's like, oh, we'll just test the simple cases, but we're actually missing out pretty hard on some of the more complicated ones, because the code itself wasn't written in a way that makes it easy to test. The code coverage report says we've covered it, but we're not really validating what it's supposed to do.
It becomes like a game where you just want to get that coverage number as high as possible to see look amazing, but really it's not helping that much.
Exactly.
Yeah, code coverage is one of those things I have like a total love-hate relationship with, and I'm more hate than love, because it causes way more damage, I think, in our community than good. I think it's this inflated thing. I actually think it's very difficult to get true 100% like unit test coverage. It's something that really requires like a lot of thought and dedication, and I see a lot of people that have close to 100% unit test coverage, even like open source libraries. And I look at their code and I'm like, I don't think that's true. And the reason why they get these inflated numbers, like just like Danny said, you have like things that are getting called, right? Like you're testing this, function A, which calls B and C, but you're not really testing B and C when you're testing A. And so, but because they're getting called and triggered or this or that, like, you're getting kind of this inflated sense of coverage. And so, unfortunately, like, it's a little bit dangerous. And so definitely make sure I would use it as a tool for like an assistive tool, right? So if it says, hey, you have this file is 100% covered, like make sure and look, like, do you actually think it's covered? And if it's not, then find out where you're not stubbing something, right? Because it can be helpful, at least in that regard. So another point that I wanted to make around tests and code coverage is that, really one of the benefits around having a lot of unit tests is it's very hard to write, for me anyway, it's very hard to write bad code when you have to test it, because I feel like when you write unit tests, you're forced to test this one thing in an atomic way, and it's really hard to kind of write like 80 line functions or 80 line methods, right? Because it gets really hard to test it. And so tests kind of, another very good kind of symbiotic effect of writing tests is that you're forced to kind of write clean modular code that's easy to test. And it's a selfish thing because you're writing the tests, right? But it's really something that everyone benefits from. So that's just another thing I consider. When I taught my pilot workshop a few weeks ago, I put together this really cool diagram, which is like, hey, like, I consider code complete, like, something is production ready when it has tests as well, so it's not just code that we should care about, it's code and tests, right? So they kind of go hand in hand. And so if you're building something for production for lots of users, just make sure that tests are not a second-class citizen, right?
Also on the code coverage thing, please let me know if you think this is not right. But if you're writing like really good tests, it should probably take you longer to write the test than it would actually to do the bit of code, right? Because you've got to test all different variations of that particular piece of code, etc. So if you're writing stuff which is really quick, just to get the kind of code coverage value up, I suppose you're just not doing it right. Would you agree?
Yeah, I would totally agree with that. And thank you so much for bringing up that point. It's not uncommon for your tests to be longer and like take more time than it did to write the code. That's expected, and so and consider that like an interest payment upfront because by having tests, you're really greatly reducing the number of regression bugs your team is going to introduce. You're greatly reducing the overall amount of time, right, that it takes to like even just learn an application or feel confident making changes. If you think of like a junior like developer coming onto your team, right? Like if there's test coverage, they're going to feel confident making their first contribution, or they're going to feel confident refactoring something because there's coverage. They're going to know what they broke, right? So and bugs are really expensive, and especially like the longer they sit inside of your code base, the more expensive they get because people forget about it, or you have new people joining the team that need to like beef up on thing X and Y before they can fix this bug, and so bugs are really expensive. So and tests crush bugs. So I'm always fixing bugs in my code when I write tests.
I think we've touched on this slightly earlier, but obviously when you're writing tests for a piece of code, it also generally just makes you rethink how you wrote the thing in the first place, assuming you writing the test retrospectively, which obviously can be a good thing as well, because like you said, it forces you to write better code because you're kind of thinking that how it's going to interact with the test, and you think, well, actually, there's a better way to solve that particular problem. So that's a good thing as well.
Yeah, totally. Like forces you to get into a different mental lens, and you're able to kind of see your code from a different light because you're now putting on your QA hat and not your like engineer hat. And so it's a great thing, and it's an experience that I really wish more product teams allowed for, and so I think one of the reasons why a lot of teams, like even if they want to write tests, they're like, oh, we can't, because when the timelines were come up for this feature, like no one accounted the time for like how much it would take for us to also write tests, and I think that's like a failure on our part as engineers, because we're responsible for the integrity of the product that we create, the quality of it, and we're building it. And so it's if you're building a house and saying, okay, it's going to take 3 weeks, but it needs paint, so I should have said it takes 4 weeks, right? Like I think when you're estimating things for your product teams, like you should be estimating it with tests, and so if we're not setting that expectation early, it just creates this weird tension, I think, in the organization, and it becomes really hard to advocate for that. So
All right, so there was one there's one other piece that I wanted to ask a question kind of to the group, and then I guess we can start getting ready to wrap up. But and that is, what is one of the most difficult things, or not even difficult, one of the trickiest things to test is, if that makes sense, because like some things we talked about, so like pure functions are good because pure functions are very easy to test. There, it's easy to account for the test cases and things like that. But what have been some of the trickiest things that you've tried to cover in unit tests specifically?
I think for me, the more difficult, I think some of the more difficult things I've encountered are mostly around uh, Node.js. I think with there's module cache that you need to be careful of. I remember that kind of biting me many years ago, and just streams, error handling. I think server side tests for me are the most like they require the most like thinking.
Yeah, I know that some of the things I've had trouble with in the past, it almost doesn't end up being like the thing. It's almost just like a gotcha. So you talked about like sharing state between tests by accident. I know there have been times where sometimes you will end up, depending on how you write your tests, like I had mine written in a way that required pretty much between each test, it would require a cleanup. And I didn't write the cleanup code correctly. And it led to a bunch of really difficult to find things. One of the other general things that I have found tricky and almost just tricky because it takes a lot of effort. But it's depending on how so you talked about managing your like your data fixtures for your mock data. If you don't do that well, it can make everything quite a bit of a pain. And I know specifically so again, I like Angular stuff. So a lot of times for like the networking layer, I'll provide a mock implementation of the networking layer. I've made mistakes in the mock before that the testing framework actually swallowed the error. And then we just ended up having like a test that just wouldn't so it would be running, 100, it would always run like 108 out of 109 tests or something like that. So that's one of the other tricky things that I've run into.
For me, so you guys are way more experienced in testing than I am, so I'm sure you've written thousands of more tests than I have. But something we touched on earlier, around like component testing and things, and getting onto the edge of where it makes more sense to start to do end-to-end testing, and trying to test how components keep state on the DOM and attributes and those kind of things. So for me, that gets quite tricky. Sometimes I think end-to-end tests can be more useful in many situations when it comes to front-end component testing.
Yeah, I agree with you 100%, Leon. I think there's a lot of complex interactivity sometimes that you really should just have captured via an end-to-end test. And Danny, like regarding managing your dependencies, that what you said around the state issue, that's like I think one of the most common problems as well. So you're in good company there.
Yeah, it can happen. It can be. It's one of those things that it can just happen by accident sometimes, and a lot of times you don't catch it until we mentioned you should be able to run tests in isolation. Sometimes it doesn't happen until you're just like, oh, I'm just going to run this one test, and then it's like, why is the result different? Yeah, that can be a fun few hours of your day.
Yeah. And, just so you know, like there's runners like Ava that like, just run tests in parallel. And so versus like Mocha that runs things one by one, you're able to kind of suss those things out, just randomizing your test order. I would recommend that to shake out bugs that you might have. I also, definitely utilize like there's flags that you can set when you're writing your tests, like environment property flags, testing, for example, or tests in test mode. Definitely utilize that. There's definitely times where you have to have some wrapper like if process.env or if test, if we're in the testing mode, export this, versus not. Like it's totally fine. It's not something that you should do all the time, right? But sometimes it does. You do need to wrap something in your code, or do something differently when you're in testing mode. So it's fine to utilize those flags. And I would, highly recommend like, using some type of HTTP interception as well to like hydrate your components with mock data.
Awesome. So we are just starting to run out of time now. So does anybody have any parting words of wisdoms around unit testing that they would like to share?
Just write tests, and it doesn't matter if it's first or last, like just write them. And please, like tests are not optional for production ready code. Tests are also not second class. Like it should be part of code that you ship. And we should need to educate our product teams and like just teams at large around like tests are not optional, right? So
I 100% agree.
Yeah, just kind of reiterating what Amal said earlier about how it's the engineer's responsibility to make sure that estimates and the quality of the work when it goes out, includes testing as much as possible. It's good to kind of get into that mindset instead of thinking it's something that you need to bolt on to a piece of work instead of actually including it in that piece of work. And as Amal said quite a few times, seeing it as part of the end product.
That's right. Yeah, and also write your code and your test as if though like an axe murderer has your address, right? So, just kidding.
All right, that is absolutely one way to think about it. So thank you, Amal and Leon, for hanging out with me on this 4th of July. Go America and all of those all those fun things. I hope everybody will listen to this probably afterwards. So I hope your 4th was full of fireworks, food, and beer. And we will talk to everybody next week on the Web Platform Podcast. Again, this was episode 165. We talked about unit testing, and it was fun.